All right. I had to take a I had to inhale so hard. Um it's day 108. Um I'm not stressed out about the stream, but I was trying to record earlier. I actually did record, but it was a challenge. It was a challenge. So, yeah, I do have some other work to do. So I'm gonna work on that, and of course, streams are daily. So, I'm here. I I didn't really think through exactly what I'm gonna work on yet, but um, I'm definitely not at a loss. I have lots and lots of options. All right, so I'm gonna make sure I light my candle today. I'm out of candles too. I feel like I need to learn how to make candles or something because I burn through them so fast. Let's see. That's a little bit better of a view, I guess, with my ratio of proportions on screen. Let's see. Okay, so I have a bunch of stuff that I need to work on, honestly. I really didn't figure out exactly what I want to do next. I'm debating on I do need to go through this video I just recorded because it's like an hour probably. But I'm gonna put that in queue. All right, the sun is like semi coming out, so that helps too. It was like gloomy. It was raining this morning. Oh, I know what I wanted to do next. It's like I need to get cozy overall. That's not it. Okay. So that I can get some work done. It's 2:30. Okay, because I want to get done and get some time. I need to get some downtime. I don't know if it's gonna be a nap or what, but I need some downtime today for sure. Let's see. Sure. Trying to think what else is on my to-do list. I've been wanting to work on today is Wednesday. First of all, Wednesdays we wear pink. I have like a whole like pink on from like I would say head to toe. Obviously my hat is not pink, but from shoulder to ankle, it's just hot pink. And yeah, I need to start busting out this pink that's in my closet. See, I feel like I need like an energy drink type. It's an energy drink type of day. Like I had some coffee earlier, but that's not cutting it. Did I eat my Twix? I ate my Twix today. See, I don't keep like sugar and stuff like that in the house. I don't have pop or anything. It's good. It keeps me from binging on sugar. But sometimes you just want like I like turtles. Turtles, Twix. Just like a good candy bar. Oh, I like Reese's Cups. This thing is not working. Okay. I need to get some G Fuel. That's what I really need in my life right now. I haven't had any around for a couple of months. It's very convenient when you're a person like me who's like, I need my perk up sometimes. Like, Miss Sainer, welcome in. How am I doing? I just need a little boost. That's what I need. I need a little afternoon kick. But that's just because I was trying to record earlier. It was a lot. I did finish my recording, but geez, I had to like stop multiple times. Justice was like doing a lot, which was, yeah, that was fun. Let's see. Same, I'm moving in slow motion. Look, okay. I had coffee earlier, but I was like, I don't think that's working. I'm so used to coffee, so sometimes it doesn't really do that much for me. They got a high protein Snickers. It's not, oh geez, 20 grams of protein. See, if that's good, that's, when did this happen? When did they start making? Okay. I'm working on getting my protein up, y'all, so when I see some high protein stuff, I'm like, hold on, wait. Can y'all hear that? It's the way I want some freaking cookies. Like, do I have cookies? I don't keep sweets in my house like that. So when I want something, it's like, oh God. I could really go for a cookie. About to go to the chiropractor. Okay. I'll be on the game later. Shoot, I'm gonna be on there too, one way or another. I need to go to the chiropractor though. My back is messed up. It's so uncomfortable. And I don't even know how to fix it at this point. All right. See, I like ghosts, but does everything have to be sour? The AI music has turned from like random generations to a playlist. I think we need to switch it up. Let's switch it up. We've been listening to the study beats version for a minute. Bluebirds. Let's try this one. Copy. Which one is it? This right here. That's better. Can I rename this? All right, this is good. This is good. All right. Yes. Dang it. Nah, I would have been looking for this freaking wallet. I migrated all the way. All right, let's see. Oh, I see. Got you, got you, got you. this a follow-up or is this a reschedule? All right, let's see. We can close all of that. All right, I got some stuff to do. Let me see. Where's the right? So I'm starting to work on my slides. I was getting ideas about this yesterday. So I'm starting to work on my slides for our conference. See, I didn't even have pink hair back then. My hair was like in a blonde phase. That's so funny. This is my old headshot, one of my old headshots from Girl Develop It. And Mac is using it as a default. This is like been up here since, it's been the default since like 2020. Let me find my picture. Let's do insert, upload. Let's see if I got it on here. Oh, there it is. Do I know how to mask? Ooh, what am I doing? Longer than 25 minutes? Yup. All right. I'm gonna see how quick I can. What's the fastest I can stream? That's crazy. I was thinking about this earlier. Like, I was really harassed for having short streams. That's crazy. You gotta do what you gotta do. You gotta do what you gotta do. I want to. I don't know what I'm doing. I'm just doing stuff. Like, let me not just be doing stuff. I can't see that part of my screen. Hold on. Okay. Jeez. Well, I feel like I don't know how to use replace the image. How do I position, rotation? It's not under there. I know I can mask this with a circle. Crop, text box, insert image. Right now I'm working on my slides. I don't really have like I don't know what I'm working on. Mask, there we go. There we go. Like, I know. Okay, are you gonna make the circle for me? Oh, perfect. Beautiful. That's beautiful. All right, see, I figured it out. But yeah, right now I am. These are my slides for hacking with the homies. Now, can I put a border around this? Border. And make it, can I change the color though? And then just make it like way thicker. because this is literally just this is just a back this is just a background. All right, that's fine, but I just want to see, I want to make the border a little bit. Oh dang, I knew that was gonna happen. Okay, I guess that's fine. I can come back to it later. Can't see because my freaking face is itching. I can't see because my microphone is in the way, but yeah, I'm working on my slides. We only get 3 slides, but I am just keeping a copy of the originals here just for reference. I at least wanted to get them started because what'll usually happen for me is I'll like be in the middle of doing something else, and then I'll get an idea like, oh, that's something I want to put into my talk, or like even as we are still working on our book, like I get like ideas and then I'll just go and work on it. So yesterday I kind of started these, but I didn't really do much with them. So I do want them to be here because I have some thoughts around, especially as I'm going through some of the as I'm going through some of the Google Cloud Next content, I'm getting ideas. Let me see, 2023. I finally found what I was looking for. The other day I was trying to find my old slides.google.com, right? I was trying to find my old presentations for conference. So this is the new one that I'm working on right now. This is 2020. In this example, we did crawl, walk, run, and I did like linear regression with and the example was from the Google machine learning crash course. That's what this one was based on. Then the next time I did a talk, these are what the flashbacks are referring to. So in 2020 we did crawl, walk, run, machine learning crash course. That was linear regression, so that was using TensorFlow. Then the next time, let me see, linear regression. The next time we did this Google Auto ML. Let me see. I think it's gonna have to be generating ID. No. see. Auto ML. Dang, where is it? I know that one is under a different. I thought I shared it though. Let's see if I can find it real quick without putting all my business out there on the internet. Share it with me because I'm pretty sure I just shared it with myself. Okay, there it is. All right, here's the other one. Okay, this is is this 2022? This is 2022 because I remember I was pregnant when we did this one. Okay. So with AutoML, we did an image classifier. We trained an image classifier, basically. So that was called Google AutoML. And then 2023, we were talking about ChatGPT. Or is it, I think it's like this, GPT, or is it GPT 3? Something like that. Dang. I'm not gonna be able to see it from here. So my goal for this talk is going to be to show basically how quickly the technology is progressing for us as developers using machine learning, based on the talks I've given over the past few years at the conference. And then I'm going to show my demos. I'm going to show like, let's hide this just so I can be more skip. Okay, so go here, and then this will be they had 3 categories that they were putting, like 3 buckets they were putting stuff into. Agent builder, model builder, and model garden. Can I make this? trying to think, how do I want to layer this? Is it like this, right? No code, and then model builder. They did like, where's my phone? It's me. I'll be right back. See myself right now. Oh, hey. Okay. Is that right? All right. No code, low code. I don't know if these are the exact terminologies I'm gonna use, but basically, let me turn this, move this out the way. We will have, there's like the different levels of getting into it basically. So you have like at the top, you have like a no code, like just configure it in the cloud type of customization. Then model builder, I have to look and see which items fall under model builder, if I would call that low code or not. I feel like it's low code though, because model builder should assume that I don't have to train my own model. That I think that's gonna be the stuff that's like they have like some adapter tuning. They have some layers of tuning, fine tuning, and probably I wonder retrieval augmented generation might fall into that category too. And then custom code, model garden, model builder. All right, let's go back. Okay, so then this is gonna be This is going to be like the 3 examples, right? So one example is going to be an agent builder, or I should say, yeah, agent builder is the service. So we'll do agent builder. I didn't decide the other 2 services yet. I think we need to do I think I want to do training with BigQuery, because BigQuery can actually train from the data. So I'm gonna do like BigQuery ML maybe. So I have to figure out, but this is kind of what I'm thinking. All right, so what's the next session I want to look at? I don't want to watch this one right now. Let me see. Take large-scale AI from research to production with Google. I want to watch this one. I don't know if this is on my list already. I want to watch this next, I think. Matter of fact, just get that part primed, because I'm gonna be mad if I have to scroll back to it. I definitely want to watch that today. I want to watch this one also. Transforming software engineering with Google AI. If this boy don't go to sleep, at this point, by the time he go to sleep, it's gonna be bedtime. Okay, so today, did I post that? Because I closed the window earlier. Hold on, let me get my window back. I need my window back. I closed the whole window earlier, and I would like it back now. History, 2 tabs, 20 tabs. That sounds about right. Okay. Because I don't want to forget about this. I can't believe he just gonna keep yelling. Okay, I want to join this hackathon. Why does it look like this? We can't see that part. Is this just a picture? It's just a screenshot, maybe. Yeah, it's a screenshot. Okay, cool. Yeah, so I'm gonna do one of these. These are all their examples. Okay. Is this the one I... Oh, man. This is the one... Okay, so this is the other one I want to watch. Oops. Alright, so that is... like an hour and a half, for real. I might rewatch the BigQuery one. Oh wow, I made it to the bottom of the list. Is this the Stack Overflow team presenting this one? Oh, a combo. Yeah, okay, let's add this to the list. Because I think what I want to present some practical like implementations and how that looks. Then I do want to highlight some of the like workflow productivity types of experiences as well when it comes to AI, right? Like the coding assistant and things like that. So these are the few videos I want to focus on for now. Pause this. Let's see. I don't really know what my neighbor's doing right now. Actually go here and then Oh, you know what? Let's just do. This is. Let's do this one first, and then this one, then this one.
Hey folks, thanks for joining us. I'm really excited today to talk about taking your AI workloads from research to production using our AI hypercomputer architecture. And I have three of the incredible co-presenters joining me today. I have Maulin Patel, he's the Director of Product Management for GKE. And I also have Curtis Kim, CEO of Cacao Brain. They're building some amazing foundation models for use cases like content generation to healthcare. And I also have Andrew Clare, CTO of Neuro. If you've noticed, if you're around in Bay Area, etc., they have some of the cutest delivery vehicles. They're bringing AI to robotics on the road. So really excited. We have a lot to cover, so let's get started. We are very fortunate to be living in an era of AI. The accuracy of AI models across a whole range of use cases is just amazing, something that was previously thought impossible. And AI models are not just understanding our world, but they're also generating our world today. However, from use cases like content generation to music composition, predicting protein structures to recommending content to customers, etc., you name it. However, that's not really news to this audience. It's all very exciting. But what keeps us up at night is how do we take all these state-of-the-art models and productionize them into our enterprise workflows. And as you do that, there are a lot of challenges. It's incredibly hard. We call that generative AI second act. But there is very complex skill set and software that's needed. There are a whole bunch of tools that open source community as well as various startups and established enterprises have created. However, those tools don't necessarily work well together. And just to create an integrated pipeline that delivers performance and productivity is a big challenge. Once you have the whole pipeline set up, getting access to infrastructure is a big challenge. And if you get access to this expensive infrastructure, keeping it productive, measuring the ROI of your AI initiatives, etc., is an incredible challenge. It turns out that at Google, we've been working on productionizing AI at large scale since our founding by the two researchers in AI over 2 decades ago. There are 5 pillars to our AI engine. First is the industry-defining AI research. Google created Transformer, which quickly became the fundamental building block for large language models. Transformers allowed us to map relationships to sequences of extremely large length. And once we basically take all this research into our state-of-the-art models. Earlier today, we saw in the keynote how our Gemini is powering some of the amazing use cases. However, it's not enough to just have these models. We have to take these models to production deployment. And that's where some of the capabilities that we bring shine, because we have the experience of productionizing AI using some of the largest applications that have over 1 billion users, including Gmail, YouTube, search, ads, maps, etc. And so all the learnings that we have from developing and running these applications at large scale, we contribute back to open source software, including frameworks like TensorFlow, JAX, our compiler XLA, and Kubernetes, with our managed Kubernetes as an example of what you can run today. And finally, to run all of this, you need incredibly performant and scalable infrastructure. So those are the 5 pillars of our AI engine, and we bring our AI engine to our cloud customers via what we call the AI hypercomputer architecture. There are 3 layers to our AI hypercomputer architecture. The base is the performance-optimized, purpose-built infrastructure. It consists of our GPUs, TPUs, CPUs, all interconnected using some of the highest bandwidth interconnects, as well as integration with the storage technologies across the different workflows. That's the base. That's the base. The idea is to deliver exceptional performance and efficiency. And in order to run all of this infrastructure, we have extensive open software. And we'll talk a little bit more about that shortly. And on top is our consumption models. So while we, of course, support the traditional cloud consumption models, including long-term reservations, on-demand consumption, as well as spot, we also have some purpose-built pricing and consumption models just suited for AI workloads, including the dynamic workload scheduler. And our managed AI stack, fully managed AI services, including Vertex AI, sits on top of our AI hypercomputer to support our customers with higher levels of abstraction. Powered by our AI hypercomputer, we're getting some great feedback from analysts. Just last month, Forrester released their wave, where they highlighted how we have strength, not just in our current offerings, but our strategy going forward. In fact, we received highest marks of any vendor in their report on both of those dimensions. And we received full marks in 17 out of the 19 criteria that they had to evaluate different AI infrastructure solutions. And of course, so it's no surprise that our customers are relying on Google Cloud to transform their AI workflows, from technology and innovation industries to financial services, consumer goods, retail, media, entertainment, medicine, and healthcare. We are working, and we are fortunate to be working with a whole host of customers across these industries. And today we'll have 2 of our pioneering customers share their experience on productionizing AI on Google Cloud. So let's start by looking at the advancements we are bringing at each layer of our stack. And at the base is, of course, our performance-optimized hardware. So before we go deep, let me take you behind the look into our warehouse-scale AI data centers.
To show you how the AI hypercomputer comes to life in a data center, let's think about how we set up a training job for machine learning.
Now, this is where it all begins, with the performance-optimized infrastructure that is at the very core of AI hypercomputer. A scheduler or an orchestrator kicks off a training job that creates a compute cluster. For AI workloads, these instances use accelerators like NVIDIA GPUs or Google Cloud TPUs. This is a compute engine rack filled with A3 VMs powered by NVIDIA's H100 Tensor Core GPUs. Our custom-designed 200 gigabit per second intelligent processing units, or IPUs, create a separate data channel for GPUs to communicate with each other and bypass that CPU host.
A TPU is a tensor processing unit. Each chip has tensor cores with 4 matrix multiplication units, or MXUs, that do the actual arithmetic. TPUs are custom-built in-house. They're specifically designed for artificial intelligence. It's all in there. On a single machine, TPUs can have 1, 4, or 8 chips, and multi-host workloads can use hundreds or even thousands of these chips together as a pod or a pod slice. Multi-slice training jobs can even use tens of thousands of chips. This is all amazing. Everything in here is at a scale that it's just hard to wrap my brain around.
And you know, When we moved to OCS for networking, we created the opportunity to reduce power consumption by up to 40%. This high-performance, energy-efficient, power-dense infrastructure offers a path to more sustainable IT. We hope that you all enjoyed this look into what makes AI hypercomputer a reality.
That's cool. I'm glad they're working on. I'm glad they're working on the power consumption because
Wow. Isn't that incredible? Every time I look at the scale, complexity, and size of our AI infrastructure and how everything just works, it just blows my mind. Let's start with our cloud TPUs. We created cloud TPUs or TPUs almost a decade ago in order to address the computing demands of our own AI workloads. And today, some of the pioneering services that you're used to, from Gmail to Maps to Search to Ads, YouTube, they're all powered by our cloud TPUs. Our latest Gemini model was trained and is served on our cloud TPUs. We are on the 5th generation of our TPUs, and earlier today, we announced general availability of TPU v5p. TPU v5p is our most powerful, scalable, and flexible cloud TPU to date. For training large language models, TPU v5p provides almost 3x more performance compared to our last generation. And what that means is you can bring down the time it takes to train the largest models from months to weeks. It's also powered by the world's highest bandwidth interchip interconnect in production today. Each chip is connected to every other chip, 4,800 gigabit per second of bandwidth, and they scale to 9,000 chips in a pod. And together with the incredible ICI, as well as the scale to 9,000 chips for distributed parallel training applications, we provide 4x more scalability. And finally, powered by 95 gigabits of HBM memory, there's a whole range of AI models that can fit in the memory capacity, from the regular dense decoder large language models to the more advanced mixture of expert models. TPU v5p supports the full range of models for training. We also have a variant of 5th generation of TPU we call v5e. It's designed for cost-efficient performance. It's our most efficient, versatile, and scalable TPU. For training large language models, it provides up to 2.3 times more performance compared to our last generation TPU. And for serving, it provides 2.7 times more performance. It's also incredibly versatile. It supports a whole range of precisions, and it supports shapes from one chip shape all the way to 256 chips interconnected by our interchip interconnect. So you can run small models, as well as you can go all the way up to 2 trillion parameter models to run them efficiently for inference. And finally, because it's a TPU, it's designed to scale. Last year, we announced the world's largest scaling training application, scaling a workload to 50,000 chips and delivering great performance. In addition to our cloud TPUs, we also support NVIDIA's cloud GPUs, or NVIDIA's GPU in our cloud platform, and we provide industry-leading capabilities. We work very closely with NVIDIA to optimize the GPU platform on Google Cloud, and there are 3 pillars to this partnership. First, it's the speed to market. We were the first cloud to bring several NVIDIA products, including L4, A100, T4, as well as the P4 GPUs in the past. Earlier at GTC, we announced we're bringing Blackwell to Google Cloud early next year. Second, it's the breadth of offering. We have a full range of GPU accelerators on our cloud to serve small models, mainstream models, as well as gigantic models, and also to train the full range of models. Finally, we are working very closely with NVIDIA to optimize the software stack so you get the best performance, productivity, and usability on top of GPUs within Google Cloud Platform. And we'll talk a lot more about some of those projects shortly. For training the largest models, as well as for serving them, we have A3 based instances, which are powered by NVIDIA's H100 instances. and we announced that the general availability of a variant of A3 called A3 Mega is happening next month. It doubles the bandwidth of accelerators from A3 to A3 Mega, and that bandwidth is 18 times more compared to our A3 instances. Each of the A3 Mega basically can scale up to 26 exaflops of computing. So you can buy instances at a smaller scale of up to 8 chips in an instance, all the way to 26 exaflops of computing in a gigantic supercomputer.
Exaflops.
And several of our pioneering customers use A3 to power their AI applications today. In addition to A3, we also have L4-based G2 instances. These are designed for very efficient serving of mainstream or smaller AI models. And we are looking forward to bringing NVIDIA's next generation Blackwell GPUs to our cloud early next year. There will be 2 variants. There is B200 and GB200, which uses ARM-based Grace chip, and it's available in the rack scale architecture of 72 GPUs connected by next generation of NVLink technology. Together with NVIDIA, we'll also network these instances using the next generation of NVIDIA networking technology. And because these chips are so powerful, they consume a lot of power, they need to be liquid cooled. This is where we again have a big advantage, because we've been working on large scale liquid cooled data centers for a while. We are on our 3rd generation of large scale liquid cooled data centers with our TPUs, and Blackwell GPUs will be featured with our 4th generation of liquid cooled technology at scale. Ultimately, it's the full range and portfolio of products that we offer to our customers, including a full range of GPUs as well as our TPUs, because AI is not just one workload. There is a big difference if you're running a small model for inference versus you're training the next generation frontier models. And no matter what's your workload, from small scale inference to the gigantic training, we have the right instance for you. Let's move on to our second layer, which is our open software enhancements. At the foundation of our open software is our Kubernetes engine. And to talk more about that, I'll invite Maulin Patel, Director of Product Management for GKE.
Thank you, Paresh. Good afternoon, everyone. My name is Maulin. I'm the Director of Product Management in Google Kubernetes Engine. A large number of our customers, such as Anthropic, Cohere, Character AI, Neuro, Walmart, many others, have built their AI platform on Google Kubernetes Engine. We studied their motivation, and we found 3 core reasons why they chose Google Kubernetes Engine. The first one is portability and customizability. Many of our customers are training and serving models across multiple cloud and on-prem. They want the freedom to write their code once and run everywhere. They also want to support many different machine learning frameworks. Kubernetes allows them the portability and customizability. The second key reason is performance and scalability. Many of our customers, such as Anthropic, are training gigantic models with hundreds of billions of parameters. Naturally, they want high-performance, scalable supercomputers to train these models and serve them at scale. The third key reason is cost efficiency. Training and serving generative AI models can be super expensive. Naturally, our customers want lower cost and higher efficiency. They want to reduce the day-2 operations cost. They want lowest possible total cost of operations. So for all these reasons, many of customers have chosen Google Kubernetes Engine as this platform of choice. Google Cloud's state-of-the-art AI platform, known as Vertex AI, also is built on Google Kubernetes Engine. In order to build generative AI applications, you have to address many complex challenges. You have to gather the data, you have to clean the data, you have to extract features, you have to build models, and then you have to provision resources to train these models. Once these models are trained and evaluated, you have to put it in production with live traffic and monitor its performance. You need very powerful platform and rich set of tooling to make this process simple, easy, scalable, repeatable, and auditable. Google Kubernetes Engine gives you the freedom to choose the right tool for your job. I'm super excited to share with you our latest and greatest innovation that will help you accelerate your journey from prototyping to production. The size of the foundation models are growing exponentially. To train massive foundation models with trillions of parameters, you need giant distributed training clusters. These clusters have to be failure resilient and in order for your training to continue making progress. I'm pleased to share that our Google Cloud TPU team ran world's largest distributed training cluster on Google Kubernetes Engine with more than 50,000 TPU v5 chips. That's a remarkable engineering feat in scalability and performance. The fundamental challenge in scaling machine learning jobs is to attain higher goodput. So what is the goodput? The goodput is the fraction of time spent doing productive work over the total elapsed time. Achieving higher goodput at scale is very, very challenging. You may wonder why. The reason is at scale, the overheads, the inefficiencies, and the failure recovery times add up very, very quickly, lowering the goodput. For example, in asynchronous distributed training, even a single node fails in a cluster, all other nodes have to wait until the failed node is either repaired or replaced. Naturally, the probability of a single node failure in a 10,000 node cluster is way, way, way higher than probability of a single node failure in a 10 node cluster. In order to recover from failures, you have to take frequent checkpoints. And loading these massive checkpoints can take really, really long time. Loading data to jumpstart the training can also take a really long time. All of this overhead add up very quickly, lowering your goodput and keeping your expensive GPUs and TPUs idle. Our DeepMind team overcame many of these challenges and achieved a mind-blowing 97% goodput while training Gemini models. Although these Gemini models were not trained on GKE, but the lessons learned are transferable. So now I'm going to share with you a series of innovations that Google Kubernetes is bringing to market to help you attain very high goodput. Not only it will help you attain goodput, but it also gives you better return on your infrastructure investments. So let's walk through those. To achieve higher goodput, you want your containers and your models to load as fast as possible. The challenge here is that in a generative AI world, the size of the containers and the model weights can be humongous, and loading them can take really, really long time, keeping your expensive GPUs and TPUs waiting. To overcome that challenge, Google Kubernetes Engine team has launched an innovative feature which allows you to preload your containers and or your model weights in the secondary boot disk. Using this feature, your workload will start really, really fast. To give you an example, the Vertex AI prediction service, which is built on Google Kubernetes Engine, implemented container preloading using secondary boot disk. And they observe a mind-blowing 29x faster time to load 16 GB containers in a running state. To achieve higher goodput, you also want your data to load as fast as possible. The challenge here is that fetching the data live from Google Cloud Storage or any other object store can be really slow, keeping your expensive GPUs and TPUs waiting and lowering your output. To address this challenge, Google Kubernetes Engine team has launched Google Cloud Storage Fuse with node local caching. With Fuse, machine learning practitioners can fetch the data from cloud storage using standard file semantics without having to implement cloud-specific APIs. With Fuse, machine learning practitioners can bring their model from other platforms and run directly on Google Kubernetes Engine without having to modify the source code. Not only it supports portability, but the best part of it is it actually speeds up data loading time using node local caching, so your training can be performed much faster and you save time and money. In our experiments, we found that Google Cloud Storage Fuse with node local caching can speed up training time by 2.2x relative to the streaming data live from GCS. Although Fuse improves the output, there is room for further improvement. Using our parallel store, you can get up to 6 times faster read throughput relative to Lustre Scratch. Parallel store also allows you to store even larger amount of data compared to GCS Fuse with local SSD. In our experiment, we found that using parallel store, we achieved 3.9x faster training time than fetching the data directly from GCS. One of the other challenges inhibiting achieving good output is inefficiencies in sharing your expensive GPUs and TPUs across multiple teams. To overcome this challenge, Google Kubernetes Engine has launched a job queuing mechanism known as Queue, which is open source and Kubernetes native. With Queue, your teams can efficiently share GPUs and TPUs. Each team gets their fair share of GPUs and TPUs, but they can also burst to reclaim the unused GPUs and TPUs of other teams. That's how you get a higher output. With Queue, your most important jobs get the highest priority, and lower priority jobs can be preempted. Queue also natively supports popular open source tools, so you can continue using your favorite tool like Ray while benefiting from the Queue. I will now walk you through a series of innovations that Google Kubernetes Engine team has brought to market to help you achieve higher output. But wait, there is even more. Now I would like to invite back Paresh to walk you through our innovations in frameworks and libraries that will help you achieve output at a higher layer.
Thank you, Malin. So we work at every layer of the stack, and that's the point of our AI hypercomputer architecture. And we innovate to solve different challenges that emerge. We are in our infancy in running AI into enterprise applications. And so I'm just going to talk about the top 5 improvements and advancements that we are bringing to our stack and that we've launched either recently or that are available at Next, starting at Next. So all of these things that I'll talk about are available for you to enjoy today. Let's start with JAX. JAX is our high-performance numerical processing framework. It's designed for large-scale machine learning. It's powered by XLA, which is a compiler-driven approach to large-scale distributed parallel computing. And together with JAX and XLA, what you get is a single controller programming model. So you can program a gigantic supercomputer and let the compiler do the distribution of how the jobs need to run at each individual devices. And that's why JAX is gaining a lot of popularity at large-scale machine learning applications. One of the things that we've realized is while compiler is really great, there are some instances where you would need to optimize specific algorithms, like if you want to have the most optimized flash attention implementation. And so we created Project Palace that enables our customers to create their own custom kernels that works in conjunction with XLA and that they can optimize further on top of. Palace, along with a whole range of custom kernels for things like flash attention, splash attention, etc., is already available. We also work very closely together with NVIDIA to optimize JAX and XLA for NVIDIA GPUs. And the chart on the middle, you see very high performance on H100 GPUs, close to the best, most optimized performance that you can get on NVIDIA GPUs today with JAX. In order to bring all of these different technologies I was talking about in an easy-to-use, directly consumable form, we created MaxText. It's an open repository with a reference implementation for dense LLMs. You can directly use MaxText for out-of-the-box performance, but you can also customize it further to fine-tune it even more. Now, with all the 5 things I'll talk about, there is a session later at Next where you can learn more about what's happening with MaxText and JAX. And MaxText is available on GitHub for you to enjoy today. Let's build together. The second project I want to highlight is Jetstream. Inference is where AI gets to work. And LLM inference has been a very dynamic field in the recent months. In fact, every day we hear a new advancement that's coming, from continuous batching to quantization improvements to ragged attention and so on and so forth. And in the past, we've had many different projects that our customers would have to integrate themselves and deploy. But now we've streamlined everything and combined all of this into a project we call Jetstream. It's designed for large-scale model inference. It's a throughput and memory-optimized inference engine for LLMs, and it supports models from both JAX and PyTorch. And several of the serving optimizations I was talking about earlier, including continuous batching, weight quantization, KV cache quantization, etc., are available already on Jetstream. And it already supports some open models, including Llama 2, as well as our open model from Google, Gemma.
So let's hope the internet stays
if you want to learn more
up and running.
Later at Next. And of course, Jetstream is available on GitHub. Let's build it together.
Is he going to say that for everyone?
The third project I want to highlight is Max Diffusion. Okay. The diffusion models are basically used to generate images given the text prompt. And in order to enable our customers to get benefit from all the innovation that's happening to train and serve diffusion models with high performance and productivity, we've created Max Diffusion project. It's a reference implementation just like how we had MaxText as a reference implementation for LLMs, and it brings optimized performance on top of our TPUs, starting with TPUs, with GPUs coming soon. And it's really designed to scale. It provides incredible performance. While latest models like SDXL 2.0 or Stable Diffusion XL, they basically, you get 1 inference per second or 1 image generated per second using some of the latest stack. On TPU V5e, using our Max Diffusion, you can generate 6 images every second. So performance is outstanding. There's a session later at Next where you can learn more about this project, and Max Diffusion is available for you to enjoy today on GitHub. Fourth project I want to highlight is PyTorch XLA. PyTorch is the most popular framework that our customers are using to create their generative AI models and to serve them. And in order to bring the benefit of XLA compilers to our PyTorch users, we created PyTorch XLA project. And we've been continuing to advance this project at a very rapid pace. When you run PyTorch with XLA, you get both high performance and portable performance across different XLA devices.
A storm just like blew
Two of my
so
favorite enhancements that are coming on top of PyTorch XLA is, first is auto sharding. Sharding is where you're distributing a large model for parallel processing across the large cluster. With auto sharding feature, the compiler automatically does this distribution. So you just specify the number of devices, and the compiler does the automatic distribution and runs it at pretty good efficiency, very close to what you get while you figure out the right sharding strategies by manual trial and error. The second is the custom kernels I talked about earlier using Palace. You can now use those custom kernels within your PyTorch workflows using PyTorch XLA. This release I talked about, PyTorch XLA 2.3 is in RC, and it's going to be available broadly to our customers soon. Again, there's a talk for knowing more about the work we are doing here, and the project is available on GitHub for you to enjoy. The final thing I want to talk about is the collaboration we're doing with Hugging Face. Earlier this year, we announced that we are doing a big partnership with Hugging Face to bring Hugging Face users to have great experience on top of Google Cloud, and that partnership is already starting to bear fruit. You can run now models from Hugging Face with Vertex AI workflows as well as using GKE. In addition, you can also train and serve models from Hugging Face not just on GPUs but also on TPUs. There is a session where you can learn more about the collaboration we're doing with Hugging Face. It's being co-presented by Hugging Face team along with Google. And of course, you can try some of the improvements. They are available on GitHub. The final thing I want to talk about is the consumption model. So one of the big challenges with AI workflows is you can either, in order to get capacity, you can use reserved instances, but you have to reserve them for a really long time, like 1 year or 3 years. What if you have short-term workloads? For short-term workloads, you can use on-demand in the spot, but the challenge is with all the capacity shortages, it's very hard to get instances available in on-demand in the short order, or for spot instances, your job can get preempted. So to solve that problem, we created dynamic workload scheduler. It's really helpful for a bunch of scenarios. So if you have predictable workloads, like you want to fine-tune your models every month on a couple of days of computing, for example, so you know that, hey, 4 days a month, you're going to fine-tune your models, you can pre-reserve the capacity at a predictable schedule using our calendar mode, and that capacity would be guaranteed to you. You don't have to do long-term reservation in order to just use the capacity for 4 days or a week in a month. The second usage is where your researchers are doing experimentation in order to find the right hyperparameters or adaptability to use cases. Sometimes those experimentation do not have to be time sensitive. And so you would want to queue them up and let the system decide when that experimentation can execute, so you can optimize on cost. You can traditionally run them on spot, but spot instances get preempted. With the dynamic workload scheduler flex start mode, your workloads will start at a different time, but they are guaranteed to complete. So there are a whole lot of advancements we went through very, very quickly. But in order to help you understand how our customers are deploying and benefiting from all the advancement we are bringing, let me invite Curtis Kim, CEO of Kakao Brain.
Now, I'm surprised Anthropic is on here because they have,
Thank you, Parjesh, for welcoming.
AWS has been throwing their name around and
everyone.
Investing
Let me say
in everything.
it is an exciting time.
I wonder how that's going to look
be in
moving
the
forward.
AI industry, but it's also intimidating moment as well. People in this room probably understand what I mean by that. So here is the foundational model from our company. As a CEO of Kakao Brain, a specialized AI research and development subsidiary of Kakao, I am excited and proud to introduce our cutting-edge foundational models. CoGPT is our 66 billion parameters model, Korean native large-scale language model that outperforms GPT-4 in several Korean benchmarks. Second, Kalo is our image generation model that outperforms SDXL and specializes in portrait photography. And the last, Kara, is our state-of-the-art medical multimodal model that can produce medical reports in seconds. So developing these foundational models, we challenged lots of key challenges. But what I mean by intimidating is that we are still in the very early stage of the technological revolution. So there are a lot of technological challenges we need to address. It's a really expensive technology. So a small decision I made can lead to multi-million-dollar cost. In this kind of uncertain market situation, I believe productivity is the key thing. How efficiently Are we doing data processing? Are we handling the hardware efficiently? What is the most cost and time-effective way to serving our model? And thanks to GCP, we think we are tackling those issues as pretty well. So as a customer of Google Cloud, let me say GCP is a full-stack AI hypercomputer architecture with productivity its core. We deployed Dataproc for data processing, and we doubled productivity in this stage. For model training, we tested TPU with JAX framework, and we got early outcome promises, at least 50% up training cost cut. And JAX and its dev community is evolving very fast, so it's a crucial decision point to reduce the trial and error.
I'm about to follow these
trial and error.
folks on
And for the
too.
inference, we use various mix of GCP platform to fast release our language model for internal usage. It's incredible because it just takes few hours to make a production level API for language model. So this kind of productivity boost is the exact thing we want to bring into the market. So let me take an example. Kara, our report generation model, is a good example for that. So here's the demo for Kara. Kara is trained on over 16 billion chest X-ray images and reading texts. That is the world's largest data set such of in this category. Kara can produce what we can call first draft of readings in mere seconds, as you can see on the screen. This is a real demonstration. You upload a medical image. The model generates the professional level reports in seconds, as you can see. But it's not just about the speed. Both of our internal validation and independent research indicate that our model already exceeds human benchmarks and in major aspects, and it's far superior than GPT-4, supercharging productivity of radiologists. As I said, it is exciting and intimidating time to be in the AI industry. With Google Cloud Platform, our models achieve a remarkable productivity boost while maintaining SOTA or cutting-edge performance like this. CodeGPT achieves comparable or compelling results compared to GPT-4 in the Korean knowledge benchmark, but we reduce training costs at half. Kalo, we beat SDXL, but its inference cost will be 6 times efficiently. Kara CXR, we didn't use the GCP at this moment, but we expect that model training and data processing efficiency will be double. Thank you for the listening, and I'm handling over to the CTO of Neuro, Andrew Clare.
All right, good afternoon, everybody. My name is Andrew Clare. I'm the CTO of Neuro. And I'll kick things off today just by introducing Neuro a little bit to everybody here. Neuro is an 8-year-old company based in Mountain View, California. We've raised about $2 billion in capital from a number of incredible investors, including SoftBank, Baillie Gifford, Fidelity, T. Rowe Price, Greylock Capital. We have a number of partners around the country that we've worked with to deploy our autonomous vehicles into a number of services that benefit communities around the country. Those partners include Kroger, Domino's, Uber Eats, FedEx, Walmart, etc. We build what we call the Neuro Driver. That is our core product. It is an AI-first L4 autonomous vehicle technology product. And I'll speak a little bit later about how we've been partnering with Google Cloud for many years in order to deploy our AI-first technology out into the world. One of the things that I'm most proud about is our proven on-road safety record. We have had driverless vehicles with nobody inside of the vehicle driving since 2020 on roads in 3 different states around the country with a pristine safety record. And we're very proud of that as a company. And what we really have done here is deploy our technology across a wide variety of vehicles, as you can see here on the screen, ranging from custom delivery vehicles on the left that we've built in-house, 3 generations of custom delivery vehicles, consumer passenger vehicles that we use for both testing as well as delivery operations, as well as a Class 8 truck that we've also been doing highway operations with. And we've designed our technology to be able to scale, and I'll speak more about that on the next slide. The Neuro Driver consists of both a hardware suite, all of the sensors, both LiDAR, camera, and radar on our vehicle, as well as an AI-first software suite that allows us to safely navigate the road on both neighborhood roads, commercial roads, and as I said, for Class 8 trucks as well in the future. We have a continuous learning operation which leverages connectivity for a number of different reasons. First of all, to be able to leverage data from on our vehicles for actually taking that data to continuously improve our AI models. Secondly, to deploy over-the-air updates to our vehicles, where we can update anything on the vehicle over the air. And third, of course, as we're deploying L4 autonomous vehicle technology, is when that vehicle needs some level of assistance, it can phone home for help and get some human assistance in those rare cases. One of the things that we're most excited about is that we recently developed and deployed a state-of-the-art transformer-based behavior world model that we used hundreds of millions of driving examples in order to train this foundation model. This foundation model then gets fine-tuned to be able to deploy our in-house planning and prediction models that are leveraging, again, state-of-the-art AI technology. We leverage petabytes of data from the sensors that are gathered on our in-house R&D fleet. As you can imagine, autonomous vehicle technology is very data hungry, very data heavy. And again, this is part of our partnership with Google Cloud to be able to leverage that much data to effectively train our models, but also to run simulation. I'll speak more about that in the next slide. One of the things that we're most excited about in terms of our partnership with Google Cloud is the ability not just to manage all of that data, but to then leverage all of the variety of Google Cloud product offerings to be able to effectively use it. So let's go into some examples. You heard earlier from Paresh about the AI hypercomputer of Google Cloud, performance-optimized hardware, open software, and flexible consumption, all of which we utilize at Neuro to train the AI-first Neuro Driver. Let me give you 3 specific examples. We run all of our cloud compute and GKE clusters with an in-house orchestration that leverages Google PubSub in order to be able to do that in a very cost-efficient and effective manner. The second key example is that recently we started to get access to TPU v5, and we moved all of our ML training from GPUs on TensorFlow over to JAX on TPU v5. We saw with that behavior world model that I mentioned earlier a 2x increase in ML model training time with no incremental increase in cost, which is a massive speed up in our ability to train really powerful large models such as that behavior world model. Finally, as I mentioned, we manage petabytes of data. And we recently in-house were developing a lot of different technology for fine-grained application of storage layers and storage access to be able to manage our costs. Yet when GCP came out with GCS AutoClass, it was a game changer for us in terms of our ability to really manage data access levels that we need in a fine-grained way to achieve really great capital efficiency. With that, I'll hand it back to Paresh.
Thank you, Andrew. You just heard from Andrew and Kim firsthand how they're using Google Cloud to power their AI workflows. AI and creating an AI platform is a full stack problem. And this is our superpower at Google. This is where we shine. We are innovating across every layer of our stack so you can productionize workloads, take them from research to production. We're out of time, but we'll be happy to take questions on the side if you have any. Thank you. Thank you for joining.
All right. I zoned out on the end, but excuse me. I really want some context because that is interesting. The next one is transforming software engineering, and then the Stack Overflow one. I'm watching both of them. Let's see.
Hello and good afternoon. Thank you for being here today. My name's Shivani, and I lead product management for a team within Google called Developer 1P. And I'm going to be joined in this session by my partner and colleague, Niranjan, who leads engineering for our workflow and AI products. Now, Developer 1P is a group inside Google that is building tools and products that are used by the thousands of developers within Google to create the products that you interact with every day. Products like search, ads, YouTube, etc. And it's tough to be here on the afternoon of the third day, but the fact that you're here tells me that you're really interested in this topic and hopefully as passionate about it as Niranjan, me, and the rest of our amazing team is. Just by a show of hands, how many of you have not heard about generative AI? Okay, that was a trick question, because if I had seen any hands up, I would have said you're still recovering from the party last night. On a more serious note, I'd love to understand just the makeup of the room here. So if I might ask, how many of you are developers or technical audiences? If you can just put your hands up. Okay.
Everybody.
A big number of people.
Basically.
And how many of you are in executive management, leadership, or business? Okay, roughly half the room. So what we're going to do today between Niranjan and myself is we're going to talk mostly about the technology side, but we will also spend a little bit of time talking about some of the business considerations. And what we're doing here is, in some ways, we are customers of the products and capabilities that you've been hearing about at the conference with Gemini, for example. And so we'll talk to you as we've adopted these and what are the experiences that we've had. So our talk is going to consist of 3 parts. I'll start by framing the opportunity. We'll then go deeper into our approach at Google and how we're applying these technologies. And then we'll wrap up with some lessons learned, some considerations, and how we see the road ahead. So, framing the opportunity. Clearly, you all are here, and like I said, probably as passionate as us about this topic. We believe AI has the potential to disrupt the software engineering process. It will affect every part of this process, including code creation, code development, migrations, testing, performance optimization, and many others. And in fact, it will create new possibilities for delivering features and functionalities out in the market. In fact, we are extremely bullish about the role that AI can play in this space and free up time for developers to focus on the things that they love most, which is creating and innovating. I was at a CTO roundtable a year ago, and in that roundtable, we were talking about the use of AI technologies in software development. And the room was divided. Half the room felt that there would be a massive adoption. The other half of the room actually were very skeptical and said that their engineers are never going to allow AI into this domain because they can build and code better than any AI can. A couple of weeks ago, I was with that same roundtable group, and not a single hand was a skeptic any longer. In fact, everyone in that discussion was, how do we do this faster? How do we create this better? How do we move this needle even faster than what we've done? Our leadership is asking for this to come through. Software development has been identified as one of the top use cases that generative AI can help with. So that tone had changed significantly. Anyone in this room relating to that journey? Can any of you relate to that journey? With a show of hands? Yeah, I see a number of people on that. So our journey on this path actually started 4 years ago. It started with some research, it started with some experimentation, and as we started doing more of that, we realized the opportunity that this enables. And in fact, Niranjan will share more about that journey over the last 4 years and how things have evolved. So when we think about applying AI, we look at the entire software development lifecycle. It's not just about the code creation, it's not just about code completion, it spans every aspect from the building, the testing, the release, operations. And as developers, our goal is to create quality code that is fast, safe, reliable, efficient, and delivers the desired outcomes for the business. For our teams within Developer 1P, it's about how do we enable our developers to do that even faster and even better. So we look, as I said, at this entire life cycle, because even if we apply AI and make one part of this life cycle faster, we could be shifting the problem from left to right, and that doesn't help us in this entire journey of delivering the code to market faster, which is why we think that it's important not just to think about one step, but the entire journey. The other part that we think about is how do you meet the users where they are? And we'll talk a little bit more about that as well. But as you think about that software development lifecycle, we've identified that there are a number of friction points for developers through this journey. We talk to our own internal development teams, individual developers, engineering managers, and there's been a number of areas where people have expressed dissatisfaction or rather opportunities for improvement. In fact, it's a well-known fact that a developer on average spends less than 40% of their time coding. Mm-hmm. This is not a Google-specific stat. It's something that's more broadly known across the market. The other parts of a developer's day are taken up by activities such as meetings, collaboration, document finding, knowledge management, things like technical debt. These are all activities that become burdensome and toil for the developer, while many of us developers really want to focus on creating code and being creative. So as I said before, we look at the applications of AI across this entire life cycle, and we've identified a number of different areas where we can bring AI into the workflow. This includes the code creation side of it, the code completion side of it, migrations, testing, builds, debugging, operational, even on the operations side, how can we understand where things are slowing down, where are the bottlenecks, and improve and make those more effective. Our goal is to meet our users where they are and to make AI just happen. We want it to be unobtrusive and we want it to be helpful. And there's some lessons that we've learned along the way that we'll share with you around how to do that. In fact, when you take a complex topic like this, it's often helpful to think about frameworks and where the AI can be helpful. So here's a framework that we've been playing around with, which looks at what is the expertise level of the user, and what's the complexity of the task at hand, and how can AI help in those different stages. So for example, if you think about a early user who is looking to build simple code. Let's say you're building greenfield code. That means it's all about what you're doing as a developer, and you don't have to care about any of the external dependencies. That's a lot simpler a task to do, and AI can actually help you often automate some of those simple code creation tasks. However, in the real world, most of us have code that already exists in our business environments. And working with that type of brownfield code requires not just knowing the logic that you want for your application as a developer, but also how does it connect with the other parts of the code that already exist? What are the dependencies? What are the intersection points? And how do you build around what's already existing in your environments? In those cases, AI can help you assist in the creation of those codes. Similarly, as you think about legacy code that exists in our environments, you might want to think about how do you migrate your code to a more modern version. Let's say going from legacy Java to a more modern, updated version of Java. Or, security and compliance mandates may have changed. Your tools may have changed. So how do you ensure your code is up to date with that? And AI can help you accelerate some of that code transformation and migration that journey entails. And finally, as you think about opportunities such as safety and performance optimization, now I'm talking not just about the human side of it, but also the machine and compute side of it. AI can help amplify the work that you're doing to optimize those areas. So with that, I want to hand over to Niranjan to talk about how we've looked at our own environment within Google, how we've taken our code base, our development stacks, and our tools, and applied AI across that spectrum. Niranjan?
All right. Thank you, Shivani. I hope everybody is having a good next so far. Hi, I'm Niranjan, and I'm going to talk about how we've been really innovating and implementing these AI capabilities over the past few years. Our journey started about 4 years ago with a very deep partnership with Google Research and DeepMind to advance the research and state of art when it comes to applying AI to software engineering. We've been working pretty closely with them to figure out, as the capabilities of LLMs grow, what does it mean for software engineering, and how can we bring sort of our insights into how development is done at Google to bear in terms of improving software engineering. At the same time, we've also been iterating and working very closely with our partners at Google. Parts of Google like YouTube and Search and Ads and Cloud, they're all individual, mature enterprise companies in their own right. They see some of the same challenges that all of you in the room see. They all have legacy code bases that go as back as 25 years. There's a lot of technical debt and complexity. And in collaborating with them and in learning from them, we've started building a good intuition of what it really means to deliver AI at enterprise scale for software engineering. A good way to think about what we do is almost as a laboratory where we can test out a lot of ideas as they are being productionized and really kind of refine the last mile of things. In fact, some of the innovations that you saw over the last few days announced here were piloted and tested internally at Google as well. So let's talk a little bit about what does it mean to do AI at enterprise scale for a large company like Google. There's a few key attributes that we like to think about it. Firstly, is your AI accessible? Now, there's a lot of AI technologies, tools, frameworks, co-pilots, this and that. And the biggest sort of feedback we hear from our partners internally is there's a lot of friction when it comes to adopting these things. And so when we work with them and when we learn from them, we really try to optimize to minimize the friction of adopting these technologies. If you meet users where they are, then it's much easier for them to onboard onto these technologies and start making progress. But it's not enough to meet them where they are. You have to take them along on the journey with you. Right? So you have to sort of grow as their capabilities grow as well. Next, People want their AI solutions to be capable. You just heard Shivani talk about going beyond code generation, and we hear that every single day when we talk to our customers internally. There's a lot of problems that these organizations deal with, everything from figuring out how to test at scale, how do you reduce the footprint of their code so that it runs more efficiently, and things like that. These are incredibly hard problems, and they're really looking forward to seeing how AI can meaningfully disrupt and help along those journeys. And lastly, and not the least, they want the AI solutions to be safe. Now, all of you here represent varying degrees of companies. You have a lot of regulations that you have to comply with, and so do we. And making sure that our AI technologies are compliant with all the constraints that organizations have to undergo becomes very important. All enterprise companies want to protect their valuable IP, and Google is no different. And we want to make sure that our AI technologies don't accidentally become attack vectors. So we spend a lot of time in hardening our AI security systems as well, so that people can be confident that they should be able to use this safely. All right. Before we actually get into how we are building this, I want to start on a lighter note. Now, if you just focus on code generation, all you've done is build like a very high-performant Formula One race car. But the complexity of the surrounding ecosystem means that you're racing that car through the gridlock streets of Manhattan. It doesn't matter how good your car is, probably a Toyota Corolla will beat you, right? And so you have to think about the whole grid. You have to think about the whole landscape. You can't just think about code generation. You have to really go beyond the code generation. By the way, as a side note, the image was generated by AI using this text as a prompt. Right. So let's talk about what does it mean to meet users where they are. In order to meet users where they are, we have invested in a very mature technical stack and a very robust technical stack so that users don't have to worry about adoption toil. They don't have to worry about safety. They can use AI in a way that actually makes sense for them. So we like to think about it as a bit of a layer cake, and we're going to unpack a little bit of it over the next few minutes. So it starts with models. Now, we've been really privileged to have been working with the Gemini team for the past 12 to 18 months. And in doing that, we've sort of identified various ways where we can sort of take advantage of the treasure trove of data that exists within all enterprises, including ours. The most valuable asset that we have from a software engineering perspective is data, telemetry, and insights. And those are incredibly important when you want to apply AI technologies for really hard problems, because it's those insights that let you figure out where is it that users are actually getting stuck. And those insights and that telemetry leads you to identify data sets that you can use for further fine-tuning and refining your models, et cetera. And so we've been fine-tuning our models and integrating them into our ecosystem, as you'll see later. And we've also going far beyond code generation and really trying to focus on next-generation capabilities like automatic bug fixing, testing, migrations. We are super excited by the long context windows with Gemini 1.5 Pro, which we're experimenting with and seeing very positive results of. And we can't wait for all of you to try it out as well. Having great models is not enough. You have to make them useful for the developers who are going to take advantage of them. In a large ecosystem like Google, it means that there could be various ways of accessing these models. And oftentimes, when we talk to our customers, they are confused. Which one is safe? Which one is not? Which one should I actually use? So we've invested in building an internal platform similar to what you see with Vertex and others, where teams within Google can really take advantage of these capabilities through easy-to-use APIs meant for software engineering workloads. These APIs make skills such as code completion, code generation, code conversations, and other things available. A lot of our customers are using these capabilities to build multiple applications. Some of them are converting UI code that was written in JavaScript into TypeScript. Many other teams are migrating their legacy code bases into more modern microservices frameworks that get used inside Google. The most amazing capabilities that we are seeing being used internally are people using these APIs and these models to improve the performance efficiency of code so that they take less compute and other resources in our data centers. However, if you look at most of the software engineers who are doing day-to-day software development, they use a standard set of applications. They use an IDE to write code. They use a code review system to communicate with each other and review the changes. They use tools like code search for finding other things in their code bases and finding similar code patterns and whatnot. They use Google Workspace to communicate with each other about technical topics. We have project management solutions. We have issue tracking solutions. This is where users live every single day. And we try to meet them where they are in a contextually important way. And it's not just about great models and great API, it's also about UX. We have an amazingly talented UX team who works with us to really figure out how can we maximize the flow state of engineers. When engineers are thinking about a hard problem, how can we not distract them, how can we keep them in the flow state, and how can we use AI to increase the amount of time that they stay in the flow state. We also do careful A/B testing and iteration to roll out these capabilities in a safe and responsible way. We want to make sure that with every feature and with every AI capability we roll out for software engineering, it is actually leading to meaningful productivity improvements and not causing undesired side effects. As an example, as we see more and more of our code written by AI, we track very regularly that that is not leading to side effects like increased rollbacks or increased defects and things like that. All right. I know this has been so dry so far, so we're going to do a little bit of demos.
I was gonna say,
But
like,
these are not your standard demos.
can I see something?
These demos, if you blink, you might miss
Comments
something,
to
because
code.
the point that we are going to try and really stress through these demos are what does it mean to deliver these AI capabilities to the users where they already are. And so you've seen a lot of demos about code generation and other things, so we tried to think about
Hmm.
About other things that we could show that really span this software delivery life cycle. So the first example that we're going to look at is code reviews. Now, should be no surprise to everyone in this room that software engineering is a team sport. Most companies don't have singleton software engineers. They have groups of engineers collaborating together, working on problems. And as people are committing code to an increasingly growing code repository, they have to go through practices of code review. In fact, code review is a very important part of engineering culture at Google. Not only is it an important part of our culture, it is increasingly becoming a regulatory requirement for many industries, including ours. Especially if you work in highly regulated industries like healthcare and finance and stuff, software supply chain security is paramount, and code reviews and having multiple eyes on code is actually becoming a requirement in various jurisdictions. However, as you go through these code review journeys, there's actually a lot of back and forth delays between the author and reviewer, and that's a big time sink. And so we've been trying to figure out how can we harness the power of AI to really shrink that. All right, so what you're seeing behind me is an example of a real code review that happened inside Google. The author made a change, sent it to a reviewer. The reviewer left a comment. And rather than waiting for this back and forth between the author and the reviewer, our AI models and our AI models suggested a fix for a change that the reviewer or the author could easily integrate into the source repo. And doing that, we found that the code review cycles have been significantly compressed. We're seeing that the lines between code authoring and code reviewing are blurring as these AI capabilities roll out more broadly. All right, so the next example is near and dear to my heart. At one point in time, I used to write code. And when I wrote code, I used to spend endless amount of time chasing down arcane errors and warnings and things that I had no idea what was happening. And as I was doing that, I would have to read through a lot of documentation. I would have to turn around and talk to people around me. I would have to research surrounding code just so that I could fix like a simple small error. So now pay attention to this demo. It seems very simple. In this case, we have a feature called build repair, where it predicts where your build is going to break, and it suggests a fix to the user. It's a very, very small feature, just a simple little UI change. But that's the tip of the iceberg. Below the surface is it hides all the complexity. It's hours and hours of research that is now avoided just because of a simple feature. Simple interventions, carefully designed user experience that really lead to productivity improvements. All right, so with that, I'm going to invite Shivani back on stage so that we can really sort of close this out and take us home. Thank you.
Thanks, Niranjan. So hopefully those demos gave you a feel for some of the things in action as we are working on them. Now, in conversations with many people, everyone wants to understand what are the benefits of using AI in the software development lifecycle. And while we understand that everything is not quantifiable, we are actively thinking about where we can bring value through the use of these technologies. In fact, as Niranjan mentioned, we have a lot of instrumentation and a lot of telemetry, so we use that to track metrics and measure performance and productivity. But we also recognize that there's a lot that are intangible that actually are very important to businesses. So what we're trying to do here today is share our learnings and also invite you to come talk to us and share your learnings so that collectively we can advance this domain of software engineering. If you think about some of the benefits, we are looking at how do we make AI help improve the developer experience. And I understand in talking to a lot of the CTOs and engineering leaders now that that's a key metric for what they look at across their organization. We also talked about creating more capacity for people to be able to innovate, making sure that the AI just works so that the developers, like Niranjan, can focus not so much on understanding other people's problems and fixing those, but actually bringing it up front in the creation side of the software. Another area that we found AI really helping is on the onboarding of new developers. So it's an industry stat that it takes a new developer roughly 3 to 6 months to become productive in a new environment. Because they need to know the existing systems, how things integrate, how things work, what's the documentation, et cetera. And we're finding that using generative AI and NLP and other ways of surfacing information can really help accelerate this onboarding of new developers. Developer productivity is something that we do look at, including how much code is written by AI. How do you think about build repairs and fixes and reviews? Improved code health, like can we help improve the code and create quality code faster and take it out to market? And also accelerate how you are launching the code into the market, which in turn actually translates to top line growth for your companies if you can get your products out faster. So I promised we'll talk a little bit about not just technical, but a few business considerations as well as you go on this journey. And so I'm not going to drain this entire slide, but maybe pick a few of the bullets on here. So, from a technology side, we think it's really important to think about the use cases. AI is a technology, and the magic happens when that technology is applied to solving a problem. So think about your own environments and where do your users have the most need, and how can AI be used in those areas. And also be flexible and adaptable. That's one of the lessons we've learned over the course of the 4 years, because this technology is moving so fast. We need to be aware and flexible to adapt to it. Niranjan talked about the data, the evals, and the telemetry. We've seen that stay consistent for us, but some of the things we're doing in other aspects sometimes can change and evolve as the technology improves. The other area of lesson learned that I'd love to share with you is around the launch and rollout side of this capability. So we deliberately started by launching to a small group of users, and then we got feedback from those users. And that really helped us evolve our own understanding of where our users found this product, these capabilities to be helpful, and how they wanted to see it in their environments. So for example, code completion, we brought it into the IDE. Now, even when we were rolling it out in the IDE, we found that we got feedback from users where we were triggering the suggestions too quickly. And so sometimes we were offering suggestions without completely understanding the user intent. And so we got feedback from our users and realized that this is actually creating a negative sentiment. So we stopped, we took a step back and made sure to have full confidence that we understood what the user was trying to do before we triggered the suggestions. Similarly, some of the suggestions that we surfaced were long text or long suggestions, which was actually harder for the developer to understand and make sense of. So we went back and we thought about how do we make those suggestions more bite-sized and consumable for the developer to adopt without having to break their flow. And then another topic I want to touch upon is the human in the loop. We see AI as helping the developers. Niranjan talked about review, especially in regulated industries. We are careful to make sure that when we show these AI activities to our users, we make sure it's clear that it's being generated and suggested by AI, and always that the human can also have a look at it before they accept it. From a business side, I would say, one of the things that we've looked at is what's the business case and ROI. This may not necessarily be financial or cost-oriented. It's also other capabilities like experience, like quality of code, that also feed into the business case that you're building for your rollouts. In fact, I was in a session earlier today where we were talking about, do you really need to fine-tune the models, or can you take your treasure trove of data and use customization and RAG models to adapt it to your own environment, which is a much lower cost and also more maintainable over the course of time. We all are aware of risks that we have to be mindful of. For example, legal, IP, privacy. Even in our own data, we're mindful to think about, is there customer information in there? Is there PII data? And making sure we take the adequate measures to protect that. And the last bucket I'll touch upon is talent. There are some people that will naturally embrace this and have no issues adopting these types of technologies. There are some developers who may already have a more prescribed way of working, and there's a change management process to get them to adopt it. So thinking about that change management for your own talent and your own users, how do you do that at scale? How do you bring the right training and education to make people conversant with these technologies? And how do you set up your organizations and hire the next level of talent? So, as we come closer to ending this session, if there's 3 things that you leave with today, I want to sum it up for you. First is meet your users where they are. Second is use your treasure trove of data to adapt the models and recommendations to your business environments. And the third is think about how you could use this technology to solve problems that deliver real value. Now, today we are at an inflection point. Technology is changing very, very rapidly, and this journey that we've been on has evolved so much over the last 4 years. In fact, a wise person said that the pace of change has never been faster than it is today, and it will never be slower. So the road ahead is going to be fast-paced, and we are excited about this journey. What I would say is to Niranjan, let's take the race car out of the gridlock streets of Manhattan. Let's fasten our seatbelts and get ready for the ride. Thank you so much.
Hello, everyone. Hey, how's it going? Welcome to next conference. Hopefully, you guys are having fun. Yeah? Well, welcome. Well, so quick show of hands here. This might be a horrible experiment, but we'll see if it works. How many people here have used Stack Overflow in their career? That's pretty much everyone. All right, awesome. That's great to see. All right, that'll hit our numbers here in a minute as well as we talk about the developer community and how many people are engaged with the Stack Overflow site. All right. Today, well, I guess we'll kick off by introducing ourselves. I always skip that part. Go ahead.
Yeah, hi, everyone. My name is Chung. I'm product manager at Google Cloud. Very nice to meet you all.
And I'm Ryan Polk, Chief Product Officer for Stack Overflow. And what we're going to talk about today are a couple of key topics to us, things that are really important to us at Stack, and really important to us in how we work with Google and the Gemini model overall. Right? And so we're going to walk through a couple of key factors. One, socially responsible AI. This is something that I think we've all been hearing about in the news, but as an organization, this is really important to Stack. Right? This is really important to our community as to how we integrate with the major LLM providers, how we provide our data to people, and how we work with them to further our community. So we're going to talk a little bit about socially responsible AI. From there, we're going to actually walk into some of the mock-ups around how our products are going to be working together. Things that we're doing on Stack Overflow and things that we're doing on Gemini for Google. All right? And so beyond that, when we get through all of that, we also want to talk a little bit about the power of the data, the power of what we're doing with Stack's data, and how we use that to create relationships in the LLM world to really drive back the value into our community. And so we're going to talk a little bit there as well. We'll have some time for Q&A, so more than happy to open this up to the crowd, and we'll be bringing a mic around shortly after we get done, so please feel free to ask questions when we get to the end. I'm going to start off by walking a little bit through Stack's journey over the last year and a half, right? It's no secret that when a major LLM came into the market a year and a half ago, we saw a little bit of waves. I wouldn't really call it disruption, I'd call it waves in the usage of our site, and behavior changes in the users on our site as well. Right? People went out to the LLMs to get a quick solution to things, but they quickly came back throughout this last year to really learn more about the answers they're looking for. Right? What we found through a bunch of different tests on our site, if you've been a user, you may have, did anybody sign up for our private labs tests around AI capabilities? Of course, the Stack team, but there's a couple other folks in here as well. We did a lot of different tests using AI capabilities on the site. What we found were a couple of different things. When we implemented a pure chatbot, we found a really cool link between satisfaction. People were getting the answers they were looking for. They were getting a quick solution, But what we found was they weren't really learning. They weren't really moving to that stage of actually digging into things and learning more from the community overall. So what we found as well was that really humans are the best source, the best resource for providing context and accurate answers to people engaging in the community. So we get a quick solution, which is amazing from the AI capabilities, but when you really want to dig in and learn, you have to get into the community itself. The AI capabilities also gave people the power of the first draft, and we're going to talk a little bit about this as we talk about the different solutions that we're putting into place. But knowledge management as a core element of what we do is still incredibly important, right? The ability to take a basic solution and then dig in behind the scenes on that, interact with community members, ask questions, engage, is an incredible portion of learning. And so what we're looking to really drive is that element of learning in our community, aided by AI capabilities. Another element that we found, we did our yearly developer survey. This is a huge survey. We had about 90,000 participants in this. We asked a couple of key AI questions in the last survey in 2023. An interesting one here. 70% of developers either are using AI capabilities or plan to use it in the near term. As this is a couple of months old already, they're probably more or less, more of them are actually in that using category. On the other side of this, though, only 42% either somewhat trust or highly trust the accuracy of the data that they're receiving, right? Well, trust is something that's interesting because we've seen the AI models, Gemini's models evolved a ton over the last couple of years. So trust isn't necessarily purely about the accuracy of the data being received, right? Trust has two basic elements when you talk about knowledge management. One, a simple question. Why is the sky blue? Why is the sky blue? I'm just screwing with you. I'm not going to actually pull you up on stage. Why is the sky blue? If I ask a friend, why is the sky blue, right? What I'll get is an answer, probably, if they know enough about this, something around the wavelength of light moving through the atmosphere and so forth, right? I'll probably trust that answer if it's a friend of mine, but if it's a stranger, what do I do? Well, the first thing I would probably do is go to the why do they know that? What are their bona fides? What is their background that tells me that that answer is correct, right? Well, if they answer, you have a PhD in physics, then I would say, oh, your bona fides are amazing, right? It'd be cool if you did have a PhD in physics, by the way. But on the other side of that, how else can I trust that if the bona fides aren't exactly what I'm looking for? Well, I can dig in. I can ask, how do they know that? Not just why. And go into the details of how they learned that activity. I can dig into the knowledge underlying what they're providing me, the quick solution they're providing me. And so what we're looking for here when building trust is providing that how. I expect in the next couple of years with Gemini, as we look at this, the bona fides are going to be there. People are just going to start to say, well, Gemini says it must be right, right? So the bona fides will be there, but the how is really what we're looking to provide in knowledge management. Socially responsible AI. This is not just a buzzword. This is actually a movement in the industry, right? This is where the industry is moving. This is something we've been experiencing and we've been promoting at the same time, right? This is a movement towards the major LLM providers creating relationships with the communities that they engage with and giving back to those communities while they consume the data from those communities, right? This shift has been dramatic over this last year. And the relationship with Google is an amazing example of a company taking socially responsible AI with full power, full steam, full energy, and being a huge backer of this. One of the key elements that we push really hard is the idea that attribution is non-negotiable. Pointing back to the source of your data, pointing back to where you are actually integrating with, and finding your solution. Put it this simply, how do you know the answer is key. We believe that content itself, as we build more and more content on the web, is still best human-driven, right? At the very least, we need to have a human in the loop in everything that we're posting, right? This is a key element of how we are creating relationships with the major LLM providers. And feedback from communities can be one of the most powerful mechanisms for training and building LLMs and AI models in the future. And so integrating into these communities is going to be a key element of every LLM provider as we evolve. What we're looking to do is set the new standard with vetted, trusted, and accurate data that will be the foundation on which technology solutions are built and delivered to our users, right? So this is a loop for us. We want to be the provider of the data. We have an incredible data set. We'll talk about that in a little bit. But why are we providing that? We're providing that to create relationships with the major providers, to then come back around and leverage those relationships to bring more and more capabilities to our community. Right? This is the loop we're looking to provide. And this is key to everything we're doing. You'll see this on our roadmap. And when we're communicating with our overall community, this is the foundation of that, providing more and more value with the relationships that we create. Google's got some great examples here coming up with how they're doing attribution and integrating back into our community. And this is something we're excited to announce at this show. Now, I will talk a little bit about how we're using Gemini as well. Oh, shoot, I'm pre-talking your slides. That's my bad. All right, I'm going to hand it over to Cheng.
Thank you, Ryan. Thank you so much. Now, let's talk about what the partnership between Google Cloud and Stack Overflow means for you, right, in your cloud experiences.
See, that's why I thought I wasn't pre-talking your slides.
That's
you
your
got me. You got me. It was good. Rewind that back. Let's talk about how we're integrating Gemini into the public Stack Overflow site. All right. Now, about a year and a half ago, this is before I joined, we had this concept of what we called staging ground. This was a capability that was really popular in our community. It was a basic concept. To understand the Stack community, you have to understand that the original mission and the continuing mission has always been for our community to be the world's software development knowledge store, right? To be the center of that software development knowledge. And one of the key elements to this, we've all kind of experienced it in some ways, is that we're relatively strict about what you ask and what you post on the site, right? Which can be a barrier to people. This is something that we take a little bit of roasting on the public sites out there for. But it's valuable because it drives the quality of the questions and the quality of the answers on our site. And so that's a valuable loop to us that we need to continue to support. As we built out Staging Ground, the basic idea here was to help improve the quality of questions by creating a review process where people posted questions and then other community members could help them review those questions, give them feedback, help them tweak it, and get that question in line with what was expected as to a good question, a high-quality question on our site. We launched this in our labs capability about a year and a half ago, tested the heck out of this, and what we found was that although this was incredibly valuable, it was also something that didn't scale, right? We were having a lot of questions moving through the process automatically because we didn't have enough people to review them on a regular basis. This is also a great example of what AI can do for us, right? It's something that we can bring these capabilities in and help the person who is crafting a question, both in how they craft it, what they're crafting, helping them with their text, helping them with their overall context of the question, looking at expected outcomes, helping them with framing and formatting and other things as an element of helping them craft. But it's still their question. They're the one writing it. They're the one who's engaging with the community. This is something that helps them build a better question and helps the community build a better knowledge store. And the implementation of Gemini here is something that is going to be the first major step in new capabilities on our site. Now, this will include, though, as I come back to that human element, the next stage. We will continue to have a community review of this, And our expectation is, as we go through the AI review, the community review will be much faster, and we can scale much more effectively, even though we are still having humans engage with each one of these questions. Right? This is important to us to make sure there is always a human in the loop as we build new community capabilities. Now I'll hand it over to Chang, and we'll go through the over Google slides.
Now it's my turn for real. Now you can see how tightly we have integrated our slides even blend together now. But again, now let's talk about what this partnership really means to you and how we are bringing the value to Google Cloud customers. So first, let me introduce you Gemini Cloud Assist. How many of you have been to the opening keynote? Quick show of hands. Majority of people. So this shouldn't be news to you. Gemini Cloud Assist brings a transformative approach to cloud management experience by leveraging cutting-edge Gen AI technologies and our deep understanding of Google Cloud. What this powerful combination brings you is really to address the complexity and challenges our customers are facing every day. Frankly speaking, a lot of cloud practitioners in our industry are facing the same challenge. Gemini Cloud Assist solidifies Google Cloud as the best cloud vendor on the market for ease of use and achieving optimal results, helping you. Now, let's take a quick look at how Gemini Cloud Assist can help you up-level your cloud management experience. First, it helps you to accelerate outcomes and achieving your cloud goals faster by assisting you from design to deployment, troubleshooting, operations, and optimization. Secondly, it simplifies your task management experience by automating and intelligently guiding you through all your cloud workflows. And third, it offers a tailored experience because Gemini knows who you are, knows your resources, so it can provide you a personalized experience based on your specific environment and your cloud resources. Finally, lastly but not leastly, from a security and compliance point of view, as a Google Cloud customer, you can directly benefit from Google's best security practices, up-to-date knowledge, and enterprise-grade security and compliance that you can trust. Again, Gemini Cloud Assist is powered by Google's Gemini family of industry-leading models. It offers Google Cloud-wide AI assistant for your entire cloud management lifecycle experience, from design to operation to optimizations. And it offers an intelligent and assisted cloud management experience that cuts costs, boosts your productivity, and fosters customer innovation. Lastly but not leastly, it's not only available on the Cloud Console, we also made it available on our Cloud Mobile app. So all of you can enjoy the power of Gemini even on the go. Okay, let's dig a little deeper into how it all comes together on Gemini Cloud Assist. This actually will show you how we integrate Stack Overflow and bring the community knowledge to benefit your cloud management experience on Google Cloud. In the center of this diagram, you'll see is our multi-model Gemini models, which are trained on massive amount of documents, books, code, video, audio, image files. And we fine-tune the foundation model for Google Cloud with our specific domain knowledge. And then each prompt user submits are also augmented with your specific context, users' information, telemetry data, and on the top left corner, you'll see Stack Overflow data, along with Google, additional Google data that we use to actually fact ground our response. This helps improve our response quality, and also this brings our unique set of capabilities to our responses that perhaps other Gen AI solutions don't have. The response can also be made on the right-hand side. You see a variety of experiences and services, including both the desktop as well mobile and various forms of experience that user can interact with. Because Gemini Cloud Assist is powered by Gemini family models, it can incorporate new sources of data to continuously improve the quality of answers. We're super, super excited to announce that this data now includes the body of Stack Overflow posts, which brings the expertise of the world's largest community of developers' knowledge right into Google Cloud's Cloud Console. Now, when Gemini gives you a response that was informed by Stack Overflow's post, you can see a call-out link at the bottom of the response, as you've seen on the animation on the right-hand side. You will see that link shows up and even marked with the Stack Overflow logo, allow you to visit the community directly. You can get more context on what this post is about, see related links, and understand how and why Gemini gave you that answer. As a summary, adding the depth and the breadth of Stack Overflow community's knowledge to Gemini helps our user to get better answers to your questions. And we're constantly updating our grounding data with the latest post so that you don't have to worry about stale answers, data cutouts, or scenarios where you're working on something brand new and you can't trust your LLMs to have the most cutting-edge answers, because we are constantly updating these data. With that, Ryan, back to you to talk about how this partnership can be mutually beneficial to both Stack Overflow customers and Google Cloud customers.
Very much so. So let's talk a little bit about the evolution of the LLM and AI market, right? And the power of the data that is provided by the Stack Overflow community. So we'll go through a couple of the stats here. I liked our impromptu survey here at the beginning. 92% of developers visit Stack Overflow regularly, right? This is a huge number, and we were close to 100% in here when we did the survey. We have 15 years of highly accurate, high quality, trusted knowledge contributed by the community. And let's be realistic here. If we went back in time 15 years and said we were going to build the perfect knowledge base for creating data for LLMs, probably couldn't have done it much better than what Stack is today. And that's important, not necessarily just for the data, but for multiple reasons, as we'll talk about as we move forward. We have over 58 million questions and answers on the site. A question is asked about every 14 seconds, and answers are provided on a much higher frequency. 69,000 technology tags, different topics on the site. And this is an interesting one. The knowledge on the site has been reused over 51 billion times. Give examples, people visiting, learning, and then other systems that are engaged or integrated with our products as well. This is the foundation of the relationships that we're creating. This is the foundation of the relationships that are driving what we're doing with Google and with other partners. This foundation is important to us not necessarily purely for the data, but for the overall capabilities that we can bring to play by leveraging that data. So you think of it as we have our community, it provides up-to-date information, it adds signals around the value of the knowledge, provides context, and it provides content for the LLMs to consume, right? Our community then interacts with Gemini, and Gemini provides value back to that community by helping us edit questions, by helping us find new areas that we would want to create questions in. There's a whole bunch of different things that we're working through here as our overall mission in engaging with AI. But the most important factor is that the AI capabilities we put into place are going to help improve interaction in the community, help make it easier to interact in the community, and help drive value to the community. And that's what this engagement around data is giving us. We believe in the end, the community can be driven to be something that is a collaboration, something is a capability of us working together with humans and AI learning from each other and helping each other to learn. And that learning is the center of what we're building as part of the Stack Overflow community. With that, I'll open it up for questions.
Well, while the staff is helping to grab the mic, let's just quickly share a few QR codes in case you have your phone with you. Feel free to pull it out. On the left-hand side is a QR code that we actually have quite a few product engineering teams and researchers are eager to speak with you to get your feedback on how do you see this relationship goes. What do you like to see, Gemini Cloud Assist can help you in your specific use cases. On the right-hand side, in case you're too busy or have other team member you want to invite, you can use that QR code to talk to us via remote or virtual meeting. And before you go to question, there's also an ebook comes with the benefit of this conference. It's authored by our Chief Evangelist Officer, Richard Schroeder. Feel free to scan the QR code to download that book. Questions?
Awesome.
Yeah.
Got one down here.
Thank you for the great presentation. I think this is a good way of creating a more collaborative work between LLM or GenAI providers and data providers, so I think that's a really good approach. I was curious if you're using, on the updated Stack Overflow data, fine-tuning on a daily basis, or if you rather use a RAG approach for the incremental updates.
Yeah, that's, I hope people can hear the question. I don't need to repeat the question, right? Yeah. Currently we're focusing on leveraging Stack Overflow data to help us improve response qualities through use of RAG. And we're not using the Stack Overflow data for fine-tuning yet. We find the RAG data is a lot more, allow us to iterate faster. We do have plan to continuously update the source data that we receive from Stack Overflow team on a regular basis.
Yeah. All right, we got right here and right there.
As a college student, I noticed that most of the questions that I have from where